Welcome to the video for the teacher model question for C1.1. So this is looking at the particle model. So it's a 6-mark question and it's asking it to evaluate the accuracy of the particle model. So it says the kinetic particle theory describes the arrangement, movement and relative energy of the particles. So I'm just going to underline these so that we talk about all 3 of them. Of the 3 states of matter, the diagrams show a model that represent the particles, solids, liquids and gas. So let's just write these down. So this is a solid one. Apologise for my bad handwriting. I'm not used to writing on a computer. So that's a solid, a liquid and a gas. Right, and evaluate the accuracy of this model. So it's talking about the arrangement. So in terms of the arrangement, this is neat ordered rows and they're close together. And the liquid is random arrangement, so you can see they're no longer neat ordered rows, so random arrangement, and they are also close together. And then we can see the gas is also random like the liquid, but it's not close together anymore, it's far apart. So in terms of movement, you can't see the movement on this model. So the movement, so the solid would be, so in the solid the particles vibrate about a fixed position. Okay, and then, sorry, my handwriting, I'm trying to get it at the right angle here. So in a liquid, they the particles move past each other. And in a gas, they're moving very fast in random directions. And none of this is shown on the diagram. So I'm just going to write myself a note that's not shown in the model. So that's one of the weaknesses of this model. And then the third one we've underlined is the energy. So solid has lower energy because the particles aren't moving as fast. The liquid is medium energy. And the gas has high energy. Okay, and you can't really see this. It's not, oh, in fact, let's save myself some time. Energy is not shown in the model, so again, that's a weakness. So if I was going from a solid to a liquid, then there's an increase in energy of those particles. And if I'm going from a liquid to a gas, which of course is evaporating or boiling, then they're also going to get an increase in energy of the particles. Now, the one that's not mentioned in the question is the forces between the particles. So although it doesn't talk about this in the question, it's also one of the things that's not represented in the model. So the forces between the particles are not shown in the diagram, in the model. So all of this at the bottom is a weakness, and the bit that's at the top, so ignoring the energy, is a strength. So it's good in that it shows the neat ordered rows and it shows the close together in the solid, and for the liquid it shows that they're randomly arranged and close together, and in the gas it shows that they're random and far apart. But it doesn't show the energy, it doesn't show the movement, and it doesn't show the forces between the particles. So when it says about evaluate the accuracy of this model, we can talk about the strengths in that it shows the arrangement and the closeness of the particles, but it doesn't show the energy, the movement and the forces between the particles. So it's a good model in terms of arrangement and space, but it's a bad model in terms of energy, forces and movement. So now what we need to do is I'm going to swap to typing, and we're going to write our 6-mark answer here. So I'm going to type this up so we can read it a bit better. So evaluate the accuracy of this model. So we're going to talk about the strength. So sorry, I can't type. I'm making typo. So the strengths of this model are that it shows well the arrangement. I'm showing off my poor typing skills here. So it shows well the arrangement and the spacing of the particles in all 3 states of matter. And then we need to explain in more detail. So in a solid, let's start a new paragraph there. So in a solid, it shows that the particles are arranged in neat ordered rows and that they are close together. In a liquid, the model shows that the particles are in a random arrangement but still close together. In a gas, the model shows that the particles so in a gas, the model shows that the particles are randomly arranged but far apart. So that's the strength of the model, and then we'll do a space and do the next paragraph. So the weaknesses of this model are that it doesn't show the differing energies, movement and forces between the particles. So in a solid, oh, I can't get a capital letter there. So in a solid, the particles have low energy and they vibrate about a fixed position. There are weak forces of attraction between the particles. And of course, those 2 things are linked. So the strong forces, my bad. So there are strong forces of attraction between the particles. And of course, these 2 things are linked. So because there's strong forces of attraction between the particles, they can't move past each other. They can only vibrate about a fixed position, and they've got low energy. So when they go to a liquid and they get more energy, that energy overcomes the force of attraction to a certain degree. So in a liquid, I missed this space out there. So in a liquid, particles have a medium amount of energy and can flow past each other. There are medium forces of attraction between the particles. And then in a gas, sorry, I've not done that right. So in a gas, the particles have a high amount of energy and move fast and in random directions. There are only very weak forces of attraction between the particles. And of course that's linked. So in a gas, because there's only very weak force of attraction between particles, they can move fast in directions away from each other. And that high amount of energy they've got has led to them overcoming the force of attraction between the particles. Right, so we're almost there now. We've made all the major points, but as a last thing, when we're evaluating something, we need to write a conclusion. So we're going to write a conclusion about whether it's accurate or not. So what I'm going to say is this model is accurate for the arrangement and spacing of the particles. However, it does not show, so it's not accurate for the energy or movement of particles or for showing forces between the particles. And the last point, which I've forgotten to put on, is that it's also a 2D model, and of course particles are three-dimensional. So the model, let's just add this, the model is only two-dimensional. Like that, lovely. It also is only two-dimensional, rather, whereas particles are arranged in 3 dimensions. Okay, so let's click off there, because ignoring typos, that's going to be your perfect answer. Okay, thank you for listening. See you next time.